Okay, so yeah, I thought in keeping with yesterday, we would do the absolute quantification tutorial, since we heard so much from Andy Hufnagel about absolute, or I guess calibrated quantification. Mike takes issue with the name absolute, so we tend to call it, and I guess Andy too, so we call it calibrated quantification. Okay. So I'm gonna drag this folder into, oh, it says replace. Let me cancel that. So I've already done this once. I'll get rid of it. So does everybody now have an absolute quantification folder? Okay, and so in here there is, or there are just a set of raw files collected from an experiment done by Andrew. Yes. What? Oh, I don't know that I use anything to open raw files on this. Photos. Wow. Okay. Not a very nice photo, is it? I usually use Skyline to open my raw files. No, actually, I will also frequently use CMS. So that's a program that comes with ProteoWizard. So here I can get a kind of an overview, see that it's an SRM file. So yeah, that's typically my simplest thing. Is I would highly encourage everybody to, oh, except for that, install CMS, install ProteoWizard, and then you'll get on your right click menu. You get the ability to bring up CMS. You also get the ability to bring up MS Convert GUI, which allows you then to convert these files into MZML. I think that's going to take a little while, so I'm going to cancel it. But anyway, so those are, I think, useful tools. Okay, so let me bring up, also on your flash drive, in the tutorial section, you should have these PDFs for all the tutorials. So this is the absolute quant tutorial, and it will give us a little bit of context about what the experiment is that we're going to look at. We're actually just going to look at one peptide, and that's the this peptide on a GST tag. So this is that experiment we talked about earlier, where the graduate student was interested in studying transcription factors, and he expressed them with E. coli. And in fact, every protein that he expressed, he put a GST tag on, which has a known peptide that he can then measure the quantity of the protein that he's generated based on the presence of this peptide. So we're going to look at his calibration curve, where he put a standard along with various femtomoles per microliter of this peptide, and then so there's the heavy peptide and the light peptide. So heavy peptide is always at 5 femtomoles per microliter, and then he varied the range. And then we have one sample where we have an unknown concentration. And so that's what we're going to do today. Okay, and the peptide, again, this is the peptide IEAIPQIDK. There it is. Okay, so let's go ahead and open Skyline. And we're just going to create a blank document. Okay, so what? No, just Skyline. Skyline Daily we'll need later this afternoon, but right now we can still stay with Skyline, what you've all been working on. So let's go back. Let's quickly review the well, these are all there. There's all the settings are in this tutorial. Yeah, I guess we'll just do what he has here. So we'll go to transition settings first. And I don't quite remember how I got in there. Oh, this was working on somebody's. So if you're on the full scan tab, it should just be disabled because it's still SRM. Today you're going to start using the full scan tab to extract chromatograms from DIA data. But we're still in a mode where we don't want to do any full scan extraction. Okay, and then we'll go to the prediction tab, which can stay the way it is. And the filter tab, I'm going to turn off this N-terminal leproline, and I'm going to go from ion 3 to last. Oh well, yeah. We'll do last ion. We'll see that this data was run with last ion -1, I think, which again was the mistake we made in communicating between software development and use. And I have P here, but I want Y. So we're going to do the full Y-ion series for charge to singly charged Y-ions. And we're not going to have a library, so that won't matter. And the instrument range, I don't think will matter either. This peptide will be well within that range. So we okay. And then for the peptide settings, digestion, trypsin, we're not even going to need any digestion for this. Prediction, we're not going to do any prediction. This isn't going to matter either. No libraries. So if you have any libraries checked here, uncheck them. And then modifications, we can leave the cysteine modification. How many people have modifications in here as well? Do people have them? Okay, so what we need is the, I guess actually if we look at our peptide, we're only going to need one of them, but we might as well do both of them. So this is a lysine terminated peptide. So we only need the lysine modification, but we want this 13C15N labeled lysine, and we might as well do arginine as well. And that would be it. Does everybody remember how you got these? Could you create them again if you had to? Yeah. And does everybody have them, or is anybody missing them? Okay, great. So then that's it for now. Eventually we'll come back to this quantification tab, but right now we're just going to focus on getting our peptide in here. Okay, so now what we're going to do is go to Edit, Insert Peptides. And this gives us the opportunity to insert a peptide list. We could actually just do this directly in Skyline. Who wants to use this UI? Who wants to just do it directly in the... Okay, we'll use this UI. You can actually just type right into this targets view, and you could achieve what we're going to do right now. So, but for now, we will go IEAP. Oops. No, IAIPQIDK. And actually, we could, if you opened up this PDF, you can also just go over here. You go to some line where you see it and copy it off. So I will, just to be absolutely sure I've got it right, I'm going to copy it, copy and paste. And then you all can double check what you've typed. And the protein name is going to be GST tag. It's just, it's just a placeholder. We could write a description about it too, but we don't need to. So let's just click insert. And then you see you get this peptide with heavy and light and Y3 through Y8 for both. And what I'm hypothesizing is that Y8 is going to turn out to be missing, even though it's totally valid. Could have been monitored, but it wasn't. So how would we, if this is what we were trying to measure in our sample, how would we get this out to our mass spectrometer? Yeah, mass spectrum. Yeah, export transition list. So file, export, transition list, single method, optimizing, standard method, or maybe we have some, we don't have a predictor, but if we had some scheduling information, we could actually schedule acquisition. And you're pretty familiar with that, so that would be fine. So let's go ahead and import the data now. We just exported the method. We ran it on the mass spectrometer on our calibration samples. So let's go file, import. We'll import everything, I think, yeah. Must save the document, so click OK to that, and I think I'm going to unplug my flash drive because that gives me some, system seems to have problems with it sometimes. So now in my documents absolute quant directory, I'm going to do absolute course and save. And now it's going to allow me to import some data. I keep meaning to turn these into MZML files. You're going to get to see how sometimes files import a lot slower. The thermo raw files import a lot slower than MZML files. So we just select all of them and click open. I think we'll get to see, so you'll see some gray here, which indicates that he actually collected data on more than just the single tag. And now I don't know, things are gonna, it takes a while for things to import. People have any questions at this point? Yes. Oh, sorry, what? Okay. There is, yeah. So the settings, if you say settings default, so yeah, so I could have made you all do that. But yeah, so if you want to start with default settings as a baseline, I mean, we went through all the tabs and we should have been synced up the same way. But yeah, if we wanted to start from default, we could have all just gone settings default. No, in general, not. The SRS, like, so there, yeah, like there are various cases where if you're going to do experiments repetitively, like, so I would say that if I'm going to be loading these same raw files a lot, which I am for these courses, then yeah, thermo raw files, for whatever reason, load really slow. WIF files are incredibly fast for SRM. You know, what? For SRM, it doesn't matter. I mean, for SRM, it would be just totally fine. You could convert all your SRM files to MZML. It just may not be necessary in a lot of cases. So in this case, in the teaching setting, yeah, this would have gone by in seconds if it had been MZML, and it's taken us minutes instead. So that's kind of disappointing. Although we can go ahead, if we've got some imported data, we can hide. So click hide. We don't have to watch this thing. And we can start organizing our windows. So if you have peak areas and retention times up, I'm going to just put them off to the side here. If you don't have them up, you can go ahead and bring them up. Does everybody know how to bring them up? And you can see, and sure enough, why it wasn't measured. And you can sort of see the shape of a calibration curve over in peak areas. You can click on the peptide and look at the peptide. Then you'll get a view of the heavy and the light beside each other, and see that the heavy is fairly constantly injected, but there's some variance in there, and so again, how do we're going to try both ways today, but how do we think is going to be the best way to get a calibrated value off of this? What are we going to do with this heavy? Are we using it as a calibrator? Yeah, we're going to use it for normalization. So we're just going our goal with the heavy here is just to remove this variance that we're seeing in signal from the light. So it's just as a normalization. We could do that with a global standard, or I think equalized medians would probably get us nowhere. But actually, no, equalized medians would work only on the heavy. So we could equalize the medians of the heavy and use that to normalize the light, which would be a lot like what we're going to do, which is just to take the ratio. So how do we think? Well, okay, so now everything's imported for me. So let's go ahead and get started on that. Let's pretend we're doing things the easy way first. We know how much, right? This is, as Andy said, gets done a lot. We know how much of that heavy standard we've injected, right? Which is 5 femtomoles. And we can just go figure out, we can just estimate the light in that unknown based on that, right? So here's our unknown here, Fox N1 GST. We can have a closer look at it, click on it, and now, if this is 5 femtomoles, heavy's 5 femtomoles. Who's going to make the first wild guess at what the light is? You're looking at them, is it going to be less or what? 4.2. So right, it's less than 5, right? We know we're saying, yeah, we think it's going to be less than the heavy, and it's going to be the ratio between the ratio that we can see between the two is going to provide us some estimate of that. And that ratio should be most accurate when? What? When they're equal, right? So when if these two lines matched up perfectly, that would be the most likely to yield the right results for us. If either one of these is really teeny, and especially when the light is really teeny, then we don't expect to get such great results. And why when the light is really teeny? The light? Which one do we know? It's when the heavy is really small? The light might be bleeding into it. No, the heavy is going to bleed into the light. So there's going to be some amount of heavy that is not, if we don't have pure heavy, we're still going to see a little bump here. If we have a huge heavy and there's something here, we'll frequently see a little bump because we have some impurity, and so we have some light from our standard. So, okay, so let's go ahead and do the straight ratio normalization, and we're going to go to start with our settings, peptide settings, quantification. Do we do any normalization? I don't think we even do any normalization. So, so there's no regression and no normalization at this point. We're just going to tell it that our units are F mole per UL. And okay. And then we're going to bring up the document grid, view document grid. And in a moment, we'll actually start playing with sample type and concentrations. But for now, we're going to go to one of these views. And that view will be peptide quantification. And I believe all we have to do is tell it our internal standard concentration, which is 5. And press enter. And now, if we go to peptide, are people there? Everybody got peptide quantification, document grid, peptide quantification. You didn't get there? Okay. So I think all you have to do at this point is document grid, peptide quantification, and set your internal standard concentration to 5. So once you're there, we're just gonna switch to peptide ratio results, and voila, we have oh, that's ratio to standard. We have normalized area, which is so normalized area. Okay, so that didn't quite work. So we're still just getting the areas and not a quantity. What we want is something to show up with femtomoles. This is peptide ratio results. So I've missed the setting. I have to figure out now. I think no, we don't. We're not doing the calibration curve. I think we actually do have to go back to peptide settings quantification and say normalization method ratio to heavy. So peptide settings quantification ratio to heavy. And then we're still not going to do any regression or tell it anything about which ones are the standards. We're going to do that in a second. But we want to get a baseline for, what happens if we do this easy peasy simple method of just injecting some standard at a known concentration and estimating based on that, which everybody does, or lots of people do. Mike was like, let's just get that working. 90% of the people are just doing that. Okay, so is everybody ready? Okay, click OK. And now we have estimates in femtomoles, right? Femtomoles per microliter. And how close was Tina on the estimate? Pretty good. 3.5 instead of, so it's visually hard to tell what that ratio is. Okay, so and then what? Yours still says normalized area? So that means either you didn't do one of those two steps. uh, you know, what's your peptide settings? Ratio to heavy and femtomoles per microliter. And then you also need to have, in your peptide quantification, you need to have 5 here. You have that? So while you're working on that, I'm going to go back to here. What? Okay. So we have estimates for everything else too, right? Okay, go ahead. What? Uh-huh. Uh-huh. Yeah, probably. Let's see, manage views. Uh, yeah, why'd you do that? I don't know. I don't know right at the at the moment. Okay, so well, we can go in and edit this view. So this will give you what this view is. So you can create your own. Yeah. So if you went to manage views and you went to peptide ratio results and not peptide RT results. Are you sure this is your peptide? Okay. So then you could go copy, and then you could say I want to open the view editor on my copy, and now you could call this peptide ratio 2, and then now you want to replicate this set of columns. Which ones are you missing? What? You don't see what? Ratio, yeah, I got rid of that one too. So, and then there's these little binoculars up in the corner here, and you can go find anything. So if you want, probably the most important ones, you don't really need the retention time, or just ratio to standard and quantification. So if you want to find those, you click the binoculars and then go ratio to standard, and that will find it. You just make sure it's checked, and that'll put it in here. And then if you go, and then again, if you type, well, quantification is right below it. So if you click ratio to standard and quantification, then I think you'll have everything you need for this tutorial. Right, and that's how you edit and modify these views, document grid views. But I think all we need is ratio to standard and quantification. So close. What? Peptide results. I don't have peptide results. Did you search for ratio to standard? Just do find ratio to standard, and it will pop you right there. Ratio to standard. So yep, then check ratio to standard, and right below it is quantification. Check that, and done. So, okay, so here we are back out to the quantification. So we can also see estimations for these other values, which are actually we know as well. So we can switch over and have a look at, let's see, can I get them side by side? Okay. Well, that's getting too small. There we go. Hard to get them both on the screen at once. You can look on yours, and I'll talk about what I see on the. So this most intense one, standard one, what's its ratio supposed to be? What is it actually? 40. So you can see how these get very big, you know, when we're supposed to be, well, actually we don't know where we're supposed to be. What's the one that's closest to 5? That is standard 3 is supposed to be 5. And in fact, it's even only 2. So yeah, so even when our peak area is, so if we actually click on, let's have a look at that one. Standard 3. So if we go back out here and click on standard 3, wow, you know, those are supposed to be the same concentration. Okay, so now let's actually do this calibrated. And we go back to the document grid. We're going to start to do some actual, we'll actually do our calibration curve. So we go back to the replicates view. So under views, choose replicates. And what we want to do is tell Skyline that all of these standards are standards. So just set the first one, press enter, and then press up arrow to select it. So that you have so that you can move the arrow keys, and then hold down the shift key and use the arrow keys to select all of the standards. And then now you can right click and fill down to set them all as standards. And then, did everybody get that? Okay. So we're setting all these first ones as standards, and then we're going to fill in the concentrations that we know they are. So again, I think as Mike and Andy have tried to explain, that if you just do that kind of internal calibration, there are lots of assumptions you're making that don't necessarily hold. The internal standard is not quantified accurately. Yeah. Okay. So you're saying it's not actually 5 femtomoles or what? Okay. Okay. But we can still use it to estimate. And that's what we're going to do. Yeah. So we can get cheaper peptides and still measure things. Okay, so let's fill this in now. The analyte concentration for 1 is 40. And then we have 12.5 and 5 and 2.5 and 1 and 0.5 and 0.25 and 0.1. Does everybody have that filled in? Okay, so now we're going to go tell Skyline that we're actually going to do some regression based on these standards that we just set up. So let's go. So we go to peptide settings again, and regression fit will be linear. And no regression weighting. And that's it. All we need to do. That's all we needed to do was say we're doing a linear regression fit. Otherwise, everything else stays the same. Okay. Click OK. And now in the document grid, I'm going to try to make it smaller so it doesn't cover quite so much. We can go to, let's see, so what view do we want to go to here? Maybe peptide quantification. So view peptide quantification, and this will give us a calibration curve to go to. So we can click here, or we can actually also go to view calibration curve. But when you have multiple, it can be really nice to click through the calibration curves through here. So here's our calibration curve. R squared of 0.999, so pretty good R squared. But the slope is not really 1 and not going through 0. And then now we can also, if you click on each point, you can see the calculated concentration of the point. So even though we've done a linear fit like that, the area, so this is sort of an expression of residuals, sort of like the area is not necessarily exactly even, yeah? Are people here? Okay, so the area, you see this little red arrowhead, that's where the point would be on the line, and this is where the point actually is. So they do deviate from each other somewhat. We can zoom into this lower part, which may be fairly, interesting, and you can see the distance between the actual point and the line, and so that's saying that the calculated concentration here is 2.0, and I'm not sure which one is this? This is number 4. So our actual was 2.5. So slightly different calculated concentration from actual concentration. And then you can see that maybe things level out at the very bottom. Yeah. There's probably some minor difference that I don't think we're going to have time to go figure out. But yeah, as we've seen before, it can be hard to follow all the steps, but there's nothing non-deterministic about this. If we had exactly the same settings, we would get exactly the same results. I can come over and look at it maybe later. Okay, so now we want to know what's our unknown. Actually, I guess we could probably just click here, right? And now we get an unknown concentration of 1.855. It just says calculated concentration if you click on this X. So you see that the X is placed on the line because we don't really know where to put it. So this is, we don't have a concentration to put it at. So we just put it on the line. So people see the estimate. It's pretty different from the straight light heavy ratio estimate. And then If we go to peptide ratio results, we can see this all in a grid form. So again, here, these are the estimated values, and you can see that things level off in these last three, right? Just as Olga was saying, that eventually we hit our lower limit of quantification. Where do people think maybe our lower limit of quantification is? Anybody want to guess? What? Yeah, standard 5, somewhere between standard 5 and 6, I would say, because standard 5 is still 1, and then everything kind of levels off, and by the time we're down to standard 8, which is supposed to be 0.1, 0.6 is sixfold too intense. So we're not really getting down to those lowest concentrations. And that's what a tool like the MS Stats calibration curves will do for you. It will just calculate that sort of stuff. Yep. They are? Huh? Yeah. Huh? Yeah.
So it's rounded to 1.5, but the second is not right. It keeps changing. So what's the true value? Like, how do I know what this the actual where should I do the integration, or just trust that what was done automatically?
Yeah, somebody did an experiment on that at the Broad Institute a while ago, and yeah, they basically did a massive manual integration of all of their data, and eventually came out and felt that there was no noticeable quantitative difference. So yeah, you're really just introducing. So there is background subtraction, and so if there's not interference, yeah, our recommendation is just leave it. Like, you're just introducing your own variance into the equation, and you're not necessarily going to get better quantitative results. Lots of people have used Skyline for lots of quantitative experiments, without doing a lot of manual integration. So I think really when you're looking at your manual integration, if you're trying to decide, do you like it or not? Yeah, like, to me, I don't know, quite widely, this all looks fine. I guess this one is the one that maybe is a little bit, I could see somebody who really was, wanting to get things perfect would want to do that. And that's the kind of thing that this person did. Like tailing peaks, he moved them out a little bit to get the full tailing, and in the end, that they decided that was not useful for them. So, and actually, let's see if we can zoom in. If you select a single transition here, and then put your cursor to the left of the y-axis, you can zoom, and now Skyline will show you how it's doing background subtraction. So that gray box is what it's calculating as background, which maybe, if anything, I would wonder if this is so when we're looking from the top, you may think it looks too wide, but right now I'm kind of wondering if maybe that's too narrow. Right? Because I don't know what is background really here. Hard to say, but that might be higher than the true background. I don't know. But this there is some area that gets subtracted. If you think that background is accurately expressed by what's over here on the left, then you would say, oh yeah, this should be moved out to here, right? So I get less background. So what you see visually and on linear scale can be very deceiving, and so Skyline is making calculations about where to put those integration boundaries, often based on things hard for you to see. So, all right. 5-minute break. Any final questions, or we have 5-minute break before Jarrett will start us off on DIA. Oh. Oh, okay. So yeah. So this nice little view that shows you the background. That my son did this last summer as an intern. And all you have to do is select a transition, right? And that will give you this shaded view. And then, because frequently it's pretty difficult to see the shaded part at this scale when we're looking at this most intense peak, even on the most intense peak. Which one's that? That's Y4? No. Y5. So you can maybe see a little gray there, but not really very much. So what you do for any of these graphs, if you want single axis zooming, you just put the cursor left or below the axis, right? And then click on the graph, and Skyline has mouse centered zooming. So what that means is, like, if I do below the x-axis and I put my mouse way over on the right, you'll see that it will zoom around where my mouse is. And then y-axis, I can zoom way down in and really give a close look at the background. So anybody have any ideas of why there's a little bit of, do other people see a little bit of space between the background, the shaded area, and the integration boundaries? Does anybody? So to get the most accurate view here, this is raw data I'm looking at. I have to go to transform interpolated, and then that space will disappear. So Skyline is actually calculating all of its areas and everything based on this interpolated data, which is very close to the raw data. But we just recently, or Nick Schulman on the team just recently made it possible in 3.7 to look at both the raw and the interpolated. All right, good.